Right, guys, let's see what the closures are being useful for inside of JavaScript. So let's say that we would like to create a counter or a function that will remember its previous value, and we can achieve this the following way. So here we have one function that initializes the counter inside of it and returns another function that increases this initial counter. So let's use this function. I'll create one variable, my counter, and I'll give a reference to the newly created function, and then I'll use my counter, and also like to print the results of running this function. So the console log my counter. So this will execute and print the results. And as you can see, initially we are having the counter variable of 0, and every consecutive run of this function will increase the number with 1. And exactly this is the magic of the closures, because we have one variable here, and we know that on each consecutive run of the function, this variable will get initialized and created and set to 0. But since we are returning a function out of this function, and the inner function actually needs to remember the local context of the outer function. So this anonymous function here remembers all the variables that have been set by make counter, and this way it holds reference to them. And we know that when we are exiting from the function, it should return, and basically the garbage collector should be clearing out all those references. So we should not have a reference to the counter, but since we have created a new function, this reference will be still alive. And exactly this feature is used by the closures. Actually, the closure is enclosing this variable and it stays locked inside of the memory. Okay, let's see another example of a closure. Let's take a look at this function. Basically, we have one function, make timer, that accepts an argument of wait time. And again, we have our counter, it's set to 0. And then we have an interval function that will execute the following code after the specified time, and it will repeat executing it actually on the intervals of this time. As you can see, the principle is the same. We are again accessing a variable counter which has been defined in the so-called mother function, and that's why it's enclosed, and each time we run this function we should be able to have our counter remembered. So if I use the make timer with, let's say, 500 milliseconds of wait time between the next execution, if I run this function, we should see that it runs and prints a number, so it works correctly. Again, the same pattern, we can see that the set interval is saving the local lexical scope, including the counter, which allows this counter to be used and persisted inside of the inner function. One more interesting thing here is that we can run multiple instances of this function, this way creating multiple timers independent of each other. So if I run the first one on 500 milliseconds and the second of 250 milliseconds, we will see that both of them will be running simultaneously at the same time, preserving their values. And that's due to the fact that the local counter variable is referencing the closure variable of counter. And each time we run the make timer function, we'll be having a new reference to this variable. So this time we're having two different references that create our two independent timers. All right, for the next example, we see that we have initially one array, and we are trying inside of a for loop to be able to create and fill this array with a function that actually logs out on the console the number of I created inside of this loop. So if we run this code, we will be able then to use our array, and if we pass, for example, 0, it should be able to show us 0 as a result. Of course, we need to run the function inside of this array, and if we pass 2, again we should have 2 as a result. But as you can see, the whole syntax here is quite complicated. Basically, we're using an immediately invoked function in order to be able to pass this I parameter here and to create a local scope that we'll be able to save our I and pass it to the console log. Otherwise, the functionality will not be possible using var. So we can simplify the syntax, and instead of var, which is function scoped and hoisted also, we'll be able to use let here. And since with let we'll be preserving the scope, the function will work correctly. So that's a solution with let. It's quite concise and a little, so we can run it, and then we can type, say, hi, again, let's say 1, and then execute the function in this array. and this should give us 1. So the functionality is the same thanks to the usage of let, which creates a block scope, and inside of this block scope we will have a separate I variable, which then we can attach to this console log function. And let's explore the third way of solving the problem. We are creating one separate function that we are executing inside of our loop, and even though we have a variable that will get overwritten, since we are passing the variable to our function and the function creates its own lexical scope, we'll be able to achieve the same proper result. So let's see this in action. So if we go and browse, let's say, the second element of the array, holding our function and execute it, we'll be able to see the proper result. So I hope with those examples, the usage closures to become way more clearer for you. And if you liked the content, please don't forget to subscribe to the channel. Thank you.